Hello, it's Eric here, and so welcome back to this series of videos on the frontiers in data science. And then, so when I say frontiers, we're talking about the latest discoveries over the last half century, And so today's video two and the last video one was just an introduction. So today we're going to take a deep dive into the first topic, yeah. And so today we're going to talk about the counterfactuals, yeah. So let me bring up that board. All right, so counterfactuals. So we're going to take a deep dive into this topic. And so the study of counterfactuals basically stems from the fact that correlation is not causation, as they always say in science. Yeah, like for example, we're talking about let's say for example economics. Yeah, economics is also a science. It's a kind of a social science. And so let's say for example, let me give you an example of why correlation is not causation. So let's say for example we're talking about beef. Beef is very important in terms of making hamburgers. Yeah. And then, so we know that the demand for beef and the supply of beef are correlated, and also the supply of beef and the beef price is correlated. Yeah, so therefore we know that they're correlated, but it doesn't mean that for example, the price of beef is affected by the demand for beef and things like that. In order to properly understand the relationship between the demand for beef, supply of beef, and the price of beef, we have to actually, there are actually two ways you can do it systematically. Yeah, you can do it using math. Yeah, that means you write down equations for each quantity. Yeah, and then you can also do it graphically. And then so the first example is I'm going to show you how to do it, using math. And then the second and the third example are going to tell you how to do it using some kind of graphical analysis, and subsequently, based on the graph, you're going to do some calculations, So let's go to the first example. So we were saying that demand, supply, and the price of beef are correlated, but it doesn't mean that the causation runs from this way or that way, And in order to properly understand the relationship between demand, supply, and price, you have to write down an equation for each quantity. Like for example, you can say, well, the demand for beef obviously is going to depend on the price of beef. So that's equation number one. And then equation number two, you can say, well, the supply of beef, obviously depends on the price of beef as well. Yeah. So that's equation number two. And then, finally, you may also want to say that, the price of beef depends on the demand for beef and the supply of beef, So therefore, the third equation says that the price of beef is a function of the demand for and the supply of beef, So now you have three equations where each variable appears in all three equations, yeah, either on the left-hand side or on the right-hand side, And so therefore, we say that all three variables are what they call endogenous variables. That means one variable can affect the other variable, and then the other variable can affect the original variable, So that's how you find out the relationship between these variables by using a system of equations, And that's why this kind of study is called a systematic or simultaneous equations model, yeah. And so that's the first example where you use math to study the causation that runs from one variable to another variable, And then the second approach to study causation is to draw some kind of a graph, So let's say, for example, here, let me introduce you some of the symbols here. So X means exogenous variable. That means it is something that is outside the system. Yeah. So here we have two exogenous variables. So let's say we are trying to study hamburger. Yeah. And then so therefore there are two variables that are outside the system of the production of hamburger. Like for example, the supply of the cattle industry. Yeah. And also the grain industry, the agricultural industry. Yeah. So let's say, for example, these two are exogenous variables. That means that they are outside the hamburger production industry, And then so then the other kind of variables is called endogenous variable, endogenous variables, yeah. And so here we have two endogenous variables. En1, the first endogenous variable is say for example beef, So beef is a kind of an endogenous variable because endogenous means that it is something that is inside the system, So let's say, for example, I want to produce hamburgers, then obviously I need beef, So beef is the quantity produced for the quantity of beef produced, in the hamburger industry, And then the second endogenous variable is of course the quantity of hamburgers produced, yeah. And then so therefore so we need the exogenous variables that are outside the system, and the endogenous variables that are inside the system, and we also need some kind of error terms. These are error terms. That means these are uncontrollable errors. Some things some things that you cannot control. But they do have an effect on the outcome of the endogenous variables. Yeah. So let's put them together and see how this path analysis, how this graph works. Yeah. So here we have two exogenous industries, yeah, the exogenous variables that are outside the system of hamburger production. So the first one is the cattle industry, and the second one is the grain industry, yeah. And we know that the cattle industry and the grain industry are related, they are correlated because if you raise cattle, you have to feed the cattle with grains, so the grains obviously are produced from the agricultural industry. So therefore, these two exogenous variables are correlated somehow, And now we're going to relate the exogenous variables to the endogenous variables, yeah. So let's say, for example, we know that the cattle industry is obviously going to affect the supply of beef, yeah, the beef production, yeah. And also the grain industry can also affect the production of beef, because grain sometimes you don't just use beef. You also use some kind of a grain to mix up with the cattle meat in order to make a beef patty. And sometimes you do that, sometimes you don't. It depends on the way you prepare the beef patties. Yeah. But let's say you do. Yeah. So then there's a relationship between the grain industry and then the production of beef. And then, so of course, the production of beef can be affected by some uncontrollable error, the errors that cannot be that is outside the control of the investigator, outside the system. Like for example, the workers working in the abattoir, yeah, and those workers, they may be in a union, or they may they require some kind of a skills, yeah, that are outside the control of the hamburger industry, And then so finally, the production of beef, of course, is going to affect the production of hamburgers, yeah, because beef is the beef patty is the main ingredient in hamburger, yeah. So therefore, the production of hamburgers is the most important, endogenous variable inside the system, But of course, it can be affected by uncontrollable errors, yeah. Like for example, the workers are working in McDonald's, yeah. They also may be unionized, or they may have some kind of a training required before you can actually flip the burgers in a McDonald's restaurant, yeah. And also, the wage, that they demand, can be affected by macroeconomic factors like inflation, yeah. So those are factors, or those are errors that are completely outside the system of the hamburger production industry, And so the arrows are talking about the direction of causation, So for example, the cattle industry, of course, is going to affect the beef production. And then the grain industry can also affect the beef patty production, because, like I said before, sometimes you want to mix up some grain, some corn, or something like that, yeah, with the ground beef in order to make a beef patty, yeah. And then the beef production, of course, is going to affect the production of the hamburgers, yeah. And then finally, the cattle industry can also directly affect the production of hamburgers, because cows, they provide some kind of fat, in the industry they call it tallow, yeah. It's some kind of fat that is very useful for making fries, French fries, or also for cooking hamburgers, And so there's a direct relationship between the cattle industry and the production of hamburgers, yeah. And then finally, the grain industry can also directly affect the production of hamburgers, because the other ingredient for hamburger is, of course, the buns, yeah, the bread, yeah, in order to encase the beef patty, And the buns and the bread, of course, is made from grains, So therefore, the grain industry can have a direct effect on the production of hamburgers, So, if you lay down all the causation arrows in a diagram like this, then you are doing what they call a path analysis, yeah. But path analysis is just to lay down the diagram, you know. But ultimately, you might want to do some calculations. Yeah, you want to calculate the chance of something affecting something else, you know. And for that, you need to do something else called Bayesian analysis. Yeah. So Bayesian analysis basically is the same as path analysis, but then you do some more calculations based on the causation paths that you lay down. Yeah. So let's say, for example, I can calculate the chance of something happening given that something else has happened. Yeah. And then, so for example, I want to calculate the probability, the chance that the price of hamburger is going to increase, given that I have observed that the price of beef has increased, but the price of cattle has not increased, but the price of grain has increased. You know, so given all these facts, you know, given that I have observed that price of beef has increased and the price of raising cattle has increased, but the price of grain has not increased. Yeah, then what is the probability that what is the chance that there's going to be inflationary pressure on the price of hamburgers? You know, so therefore, Bayesian analysis basically is a subsequent step to path analysis. Path analysis, you just lay down the causation pathways, but the Bayesian analysis, Bayesian network, you actually use the causation pathways to calculate you know, whatever probabilities or conditional probabilities or chance of something happening. Yeah. All right. So that's the kind of like a very brief introduction to the counterfactuals analysis, and so I hope I have piqued your interest in this area. I mean, this series of videos, the objective of this series of videos is not to, you know, give you really technical facts, yeah, mathematical calculations. I mean, the purpose of all these videos is just to, you know, pique your interest, and if I have done that, then I have already achieved my objective, you know. Then the next step is for you to do more further research, and hopefully you you know, you learn some of the techniques in this topic, you know. All right, so I'll see you in the next video where we talk about the next frontier in the data science. All right, see you then. Bye.